60 Minutes Rewind.
Biologist Charles Darwin began crafting his theory of evolution on a trip to the Galapagos Islands, where he discovered animals had developed unique traits that varied from island to island. Nearly 2 centuries later, on a different island, scientists aren't just observing evolution, they now have the technology to shape it. This past year, we met a team of modern-day Darwins on Nantucket, where they're hoping to use genetic engineering to reduce the transmission of Lyme disease, a tick-borne illness found primarily in the Northeast and upper Midwest, but also throughout the United States. The scientists' target may surprise you. It's not the deer often associated with the disease or even the ticks, but wild mice, the main carriers of Lyme. It's a first-of-its-kind approach where scientists and locals are working together to decide whether to sculpt evolution. 30 miles off the coast of Cape Cod, Massachusetts, is the island of Nantucket, a 14-mile-long, 3-mile-wide oasis known for its natural beauty, pristine shorelines, and protected landscape. But hidden is a scourge that's afflicted 15% of its residents.
The natural disaster in our area is not hurricanes or tornadoes or earthquakes. It is Lyme disease. It is the one plague that might be severe enough that communities might want to engineer a wild organism in order to get rid of it, or at least reduce the level of Lyme.
Last October, deep in the island's brush, we found MIT Associate Professor Kevin Esvelt, a pioneer in genetic engineering, waving a white flag in search of ticks.
So we just grab it.
These tiny vectors of Lyme disease were not hard to find.
And we just pop it in.
These are the big ones,
Yeah.
because these are largely adults.
If the adults are this small, imagine the tiny, what are they called, nymphs?
Nymphs, yeah. We often think of poppy seed sized.
Esvelt's collaborator is Sam Telford, an epidemiologist at Tufts University who's been studying ticks on Nantucket for the last 40 years.
There's a 50% chance, maybe more, that this is actually carrying Lyme disease.
But you're not afraid because it has to be attached
for more than 24 hours.
right, to infect you.
That's correct. These guys will swell up
Yeah.
50 to 100 times that size with blood. You know, it becomes that big.
And that's how you know when they're engorged, you know that they've been feeding on you.
If you see it that big, then you're in trouble.
The scientists aren't here just to collect ticks. They're interested in this critter.
This is a wild mouse,
This is a wild white-footed mouse.
and you've tagged it?
I've tagged it, so when I come back in April or May of next year, we get an idea of what overwintering success is.
Telford is tracking the mouse population on Nantucket as part of a novel project. The scientists want to use genetic engineering to interrupt a cycle of infection necessary for Lyme disease to flourish. White-footed mice are the main host of Lyme bacteria. When an uninfected tick bites an infected mouse, the bacteria transfer to the tick. When that infected tick then bites an uninfected mouse, the cycle continues. Deer don't get infected, but they help spread the disease because ticks embed on them to feed, then reproduce, with a single female tick laying as many as 2,000 eggs. Here's Esvelt and Telford's big idea. Change the genetic makeup of the mice so they're immune to Lyme. That way, the ticks that bite them won't get infected.
You don't have to kill the mouse in order to interrupt the cycle.
It'd be so much more economical and straightforward to just go out and poison all the mice, right? Get rid of the mice. But then there's a whole food chain that might depend on these mice that would be impacted.
The dream is that we can use new technologies to ensure that wild creatures can live in peace, playing their normal ecological role, but without causing disease that make people suffer.
Come on in, Winnie.
If Esvelt's dream becomes a reality, 80-year-old Dr. Timothy Lepre might finally be able to retire.
So, how did you get Lyme disease, do you think, Winnie?
Was it because of the tick behind my ear?
Over the past 40 years, he's been the island's emergency room head, sole surgeon, even its medical examiner. Today, Dr. Lepre runs the only private practice on Nantucket, where he treats dozens of patients with Lyme disease each year.
Follow my finger.
And yes, That's a giant tick in his waiting room.
Being in private practice, it is, while not well paid.
You get paid in like what? Chickens and donuts and.
We prefer lobsters, actually. Lobsters, clams, and scallops.
But you'll take anything, right?
I will take anything. Come on down, Shauna.
Lyme disease can be treated with antibiotics, but if left untreated, the infection can spread to the heart, joints, and nervous system, as it did for 33-year-old Shauna Asplint.
My body hurts all the time.
Okay.
I don't know if that's from my Lyme disease or what. My neck is stiff, my ankles are sore, and my hips.
Asplint was first diagnosed with Lyme when she was 10 years old. A few years later, the left side of her face stopped moving. A residual effect from the disease is still noticeable today.
Let's see you smile.
It's still
Yeah.
a little off, and then if
Yeah,
I
no.
raise my eyebrows, it just doesn't move.
We see people with facial palsies. We see little kids with swollen knees. We see people with Lyme rashes. So it alters people's behavior and activities.
The problem on Nantucket can be traced back to 1926, when locals voted to import 2 female deer to the island to give a lone buck company. As the deer population grew, so did the ticks. On top of that, by the 1950s, half the land on the island was put into conservation. The untamed brush and wild grasslands create an ideal ecosystem for Lyme's host to thrive.
We have a problem with tick-borne disease because we engineered the environment to maximize the number of ticks and to maximize the number of mice that are the best host of Lyme disease. And it came back and bit us, literally.
A trip at age 11 to the Galapagos Islands sparked Esvelt's lifelong obsession with evolution. In 2013, he was the first to propose that CRISPR, a revolutionary technology that enables scientists to edit DNA, could be used to change a species' genetics in perpetuity, hacking the laws of inheritance.
I mean, it's not like we won a fitness advantage.
This idea led to the project they call Mice Against Ticks in the sculpting evolution lab Esvelt runs at MIT. For the last 9 years, he and researcher Joanna Buchthal have been studying whether they could add a gene for an antibody that prevents Lyme infection to a mouse embryo that, as we see here, has progressed into 2 cells.
Is it going to be into one of those cells or both of them?
So our technique involves injecting both cells to maximize the likelihood that we get the antibody gene in their DNA.
Buchthal and embryologist Zach Hill showed us how they genetically engineer lab mice.
He's going to actually inject through the plasma membrane and into the nucleus for both of these cells.
How are you at darts?
Not very good.
But you're going to
A lot better at this.
You're going to hit the center of this.
Oh yeah, okay. So I already have an embryo set up on the dish here. So I'm just trying to find the nucleus here.
It is amazing to see this.
So that little burst that you can see in the nucleus is when he's actually injecting the genome engineering tools directly into the nucleus where the DNA is.
The injection mix contains both the antibody gene and CRISPR, which acts like molecular scissors. After CRISPR finds and cuts the targeted area of DNA, the cell inserts the gene into the mouse's genetic code. When this mouse is born, it will be immune to Lyme disease, and so will its children.
If I get a polio vaccine, my kids aren't going to be immune to polio unless they get the vaccine too.
That's exactly right. So this is a heritable immunization.
What do you mean by that?
What we're actually doing is we're encoding immunity so that that immunity is passed on generationally. And every mouse that gets the antibody gene is actually immune.
Typical standard evolution happened very slowly, right? Over thousands, maybe millions of years. Are you speeding up evolution here?
We are absolutely speeding up evolution, and that's precisely why we have to be careful, because we are doing things that couldn't happen naturally.
The plan is to release thousands of engineered mice on Nantucket over time, starting during the winter months, when the native mouse population is low. But first, Esvelt needs community buy-in. He chose Nantucket not only for its high rate of Lyme, but also for its tight-knit, well-educated community with a tradition of town hall democracy.
I am going to call the October 23rd Select Board meeting to order at 5:30 p.m.
We also need to start small.
We saw this in action last fall when, for the 10th time, the scientists presented their latest findings to locals.
So it appears that we have indeed produced the first heritably Lyme-immune laboratory mice capable of breaking the disease transmission cycle.
Followed by a public Q&A.
We have a huge population of field mice here. Shall we expect a larger population?
Having had Lyme disease twice, I thought, what a cool idea. But mice are kind of the foundation of the food chain. So tinkering with the food chain makes me a little cautious.
How long before it's actually going to take effect and keep me from getting Lyme disease again?
When you're in these meetings, what's that been like?
Some people are really gung-ho about this. Some people have deep reservations. But what I found heartening about this, and Nantucket in particular, is that pretty much everyone agrees that this is how we should go about developing these kinds of technologies. That it should not just be scientists in their laboratories get a clever idea, and then boom, it's there.
Dr. Timothy Lepre says he's supportive of the proposal.
Right here.
But as an avid falconer, he wants more testing to be done to ensure there won't be unintended consequences to the island's ecosystem.
Could a change in the field mouse lead to a change in the hawk?
Well, that's the question. I don't think so.
But we don't know.
But I think that has to be shown.
Do you worry about fooling around with Mother Nature?
Absolutely, but on the other hand, I'm not terribly fond of Mother Nature if she's going to give my kids disease. All of technology is saying to Mother Nature, you're beautiful and we appreciate you very much and we need to conserve you, but we're not always happy with the way things work naturally. And so we're going to change it.
But in this case, you're changing the environment for everybody.
This is, I agree, different because it's hard for individuals to opt out. And I think that means we need to do the science differently because we need to ensure that people have a voice early enough to actually influence the direction that the technology is developed.
If federal and state regulators agree, the team plans to first release the engineered mice in a small field trial on a private island so they can better understand the ecological impacts before any potential experiments on Nantucket.
What is the home run for you?
I think it's a field trial that works. It's something that allows us to dramatically reduce the fraction of ticks that are infected, that doesn't have anything obviously go wrong with the ecosystem. And then the community has a good discussion, and then they decide. And I think there's benefits, as we discussed, even if they say no, and then we walk away.